Developers, any developers in here? Whoa, what are you guys doing in here? This is a performance session. What are you thinking? Okay, I'm not going to open Visual Studio in this one, so if you want to leave now, you ain't going to hurt my feelings. Tomorrow in my rest session, you can come and we'll do some hardcore code. We'll do a little PowerShell in this one. All right, so how many of you have server farms with more than 3 production front-end servers other than SQL? Get out of here, really? That's it? 2 servers in production? Yeah, I'm not going to ask if anybody's single server. I don't even want to know. All right, most of what we're going to talk about today applies at a little bit of the larger end of the scale, okay? So I just want to prep you. Some of this you'll be able to implement in your smaller environments. A lot of these principles still apply, but we are going to talk about some of the larger architectural issues. Now, of course, you may be on a smaller farm now and moving to a bigger farm in the future, and this will help you to architect and plan for that. So for those of you who don't know me, I see a few new faces. You will notice I'm not exactly from around here. My accent's a little bit different, north of Manchester. I do spend a lot of time over here, however, so those of you who know me know I have the worst diction in the world because I use a lot of British sayings, even though they don't sound right coming out of my mouth. So if you hear them this afternoon, please forgive me for my terrible speech. I will, however, let you know that it bothers my redneck buddies back home when I say things like, "Oi, he's a complete tosser, isn't he?" It doesn't make me popular. All right, but I know better beer than they do. So, all right. So here's all the ways to get a hold of me should you decide to do so. This is a little faded out here, but best way is to shoot me an email. If you want to get in touch with me, ask me any questions, put SP Evo or Evolutions or something in the title so it doesn't go right to the round bin. Social to me is at the pub with a pint. So if you're looking for me on Facebook and Twitter, rarely will you find me there. Feel free to leave me a message, but don't be offended if it takes some time to get back to you. However, if you buy me a beer, answers will be immediate. So you know, all right? Okay, a few things I want to point out. Is Wes in here this afternoon? Is Wes Hackett in here? Okay, for those of you who are devs, a couple of things you need to know. How many of you are using the CKS dev tools in SharePoint 2010? Fantastic. He just released some of the 2013 tools for Visual Studio 2012. So he'll be running around here a little bit later. If you get a chance, stop and talk to him. But those are just fresh out. If you're doing 2013 development, you definitely want those. For those of you still on 2010, if you haven't looked into the patterns and practices stuff, you need to do that. spg.codeplex.com. There's a bunch of free code there that you can use in your applications, and a lot of good stuff, especially around BCS and some of the heavy, more arcane stuff. All right, so let's go ahead and rock and roll. How many of you were at SPC? Anybody? All right, SP Yoda is back today and today only. Right? We had a lot of fun with this. I did, however, leave the lightsaber at home. I didn't make it through Heathrow. We had a lot of fun with this at SPC, so we're going to do it again for this week. So there are a few nuggets of Yoda wisdom in here. Let's start with a little bit of an overview for you. This is what we're going to talk about. First, we're going to talk a little bit about architecture, everybody's favorite topic. And then we're going to move into some of the cool new stuff in SharePoint 2013. We're going to start with the distributed cache. Then we're going to move on to talking about request management. Then a little bit about shredded storage, one of my favorite new features. And then finally, we're going to talk about some improvements in the UI. It's not just all pretty moving pictures as Steve showed this morning. There actually are some under the hood improvements there. But before we get into all that stuff, you need to know that everything you've learned up to date is worthless and you have to learn again. No. Everything that you've learned up to date is still valid in SharePoint 2013. Yes, this is a major new release, but it's not as major as, say, the shift from 2007 to 2010 in terms of an architecture perspective, okay? All of the old rules still apply. Some things that you need to be aware of when you're designing your SharePoint 2013 environment. Do the same things that you did in 2010. Build your farm to suit the purpose for which it was intended. If you're building a large public website, your farm architecture is going to look different than it would if you were building an internal collaboration environment. If you're doing a lot of stuff with Office web apps or Excel services or Access services or Performance Point, you have a heavier middle tier in your environment than you do a front end tier. So you need to plan your farms accordingly. There are some significant architectural changes that we're going to talk about here in a few minutes, but start with the end in mind. Understand where you're going in this farm before you start putting an architecture together. Second of all, network is just as important, if not more important than it ever was in the past. Just taking all your servers and plugging them into a single gigabit network port on your switch is not sufficient, especially if you're plugging your database into that same port. Bad idea. Plan your network architecture, especially when it comes to search. Search in SharePoint 2013 is always on. That means fast is constantly crawling your front-end websites. If you leave it in its default configuration, it's going to go out and back in the same ports to call your front-end web servers that all of your user traffic is coming over. That's a really bad idea. Plan to isolate your search infrastructure, set up, as we did in 2010, set up web front-end roles that are isolated for search crawling. It's extremely important in 2013. The database still rules the roost. In every performance optimization engagement I've ever done, there's always been issues with the database. Either they're not defragging the indexes, they haven't paid attention to what's going on in the disk subsystem, they believe the IT guys when they said, oh yeah, we got a fast SAN, it's cool, it's as big as a icebox, and it's got blinking lights, it's awesome, right? No, that's a load of hooey. It's probably not very awesome if they haven't optimized it. You need to sit down with your DBAs and ask questions like, what LUNs are you assigning me? Where are you putting my log files as opposed to my data files, right? Have you aligned the spindles? Have you done all these things that are necessary for good database performance? 2013 has even more databases than 2010 did, so this is critically important. If you're not doing compression on your web front-end servers, 2012, Server 2012, if you're running in that environment, isn't any better than 2008 R2 was. Compression is enabled, but it's set to the lowest level. If you're doing things like public website publishing, you need to dial that compression up in those environments. There's so much script now that gets downloaded to those clients hitting your website for all the jQuery UI goodness that's going on. You need to make sure all of that is as optimized as possible. Make sure your cache is running efficiently. We're going to talk about some of the new caching mechanisms in SharePoint 2013, but know what the blob cache does, know how it's used, know where it can benefit you, and where it can bite you in the rear end. All right? And make sure you're implementing it effectively. And whatever you do, don't put the blob cache on the C drive, please. Okay? All right. Where am I? Are there any designers that snuck in the room? Where's Waterman? She's not in here. Either is Gowan. All right. Look, it's okay to make it look pretty, but let's make it perform better first. Okay? Don't give me a CSS file that's 8,000 lines long with 1 trillion bits of white space in it. Minify that stuff for me before you deliver it. Oh, and by the way, don't just stick it in a style library and think that's good enough. Right? Give me the option of how I want to deploy it. If, for example, I want to deploy it to disk in the layouts directory and cache it, or better yet, let me deploy it to the style library as a module, meaning it still can be on the disk system, instead of you going in and fiddling with it and now putting it into my content database. Okay? All right, how many of you are guilty of customizing pages with SharePoint Designer? Come on. I know you're out there. Don't lie to me. You've done it. Okay? All right. This is still a bad equation. Fortunately, in 2013, at least from our perspective, they've taken the visual designer out, so now it's harder for you to munge it up. However, if you're still doing this, stop it. Okay? Duplicating that content into the content database makes your pages load slower. Please don't do that in production. All right, architecture. 2007 and 2010, fairly straightforward for the most part from an architectural perspective. We really had 3 basic tiers that we were dealing with. We had our bottom database tier, which we could have had multiple failover databases in if we chose to. Then we had our application and index tier. Usually pretty basic. You may have had a couple of different app servers for Excel services or something else. Mostly if you were going to change something up here, it would be on search, where you would expand this out with different crawl and query components and whatnot. But for the most part, it was a fairly static layer. Then we had our users coming in through our web front ends. Again, like we talked about, hopefully you're isolating your search away from these web front ends. But it was a fairly static kind of configuration. We could plan pretty effectively for it, and we scaled each tier out mostly linearly, okay, in 2007 and 2010. 2013 changes this ball game entirely. Okay? So let's start with the same levels of tiers. That really hasn't changed. We have our database layer, we have our apps layer, and we have our web layer. But there's some new components in 2013 that you need to be aware of. The first off is always-on databases. Okay? If you're in an always-on configuration, you now have two massive SQL instances that you need to manage, and you need to be really careful about the yellow arrow in the middle. right? That's your latency between your databases, okay? This is key critical. Lose a transaction in there and you've lost data in SharePoint. You have to plan for always on very, very carefully. You also need to be aware of things like Office web apps. These now run preferably on their own server in your environment, okay? Now you're adding another box to the scenario. Is that box enough? Have you sized it properly? Where does it exist on the network? Are users coming to it directly, or are they going through your web front ends to get there, right? And how heavy are they using that in your environment? You may choose not to use Office web apps at all. That's fine. But if you do, think about how they fit into your architecture. Workflow, completely new animal in 2013. Runs on its own server, right? Consumes a bunch of resources. A lot of network communication going back if you're doing a lot of workflow. You need to plan for where this is going to exist in your architecture as well. There's some other key components that you're really going to be concerned about as your farms get larger. The first is distributed cache. We have a new caching mechanism. We're going to talk more about it here in a moment. But this caching mechanism can run either on your web front-end servers or isolated. I highly recommend that if you're going to use the distributed cache to any significant degree, that you run it on its own servers. Likewise, we have a brand new mechanism called request management. How many of you went to Spence's session this morning on request management? Okay, so this is, I feel, a really critical new piece of the architecture. As you're planning out your farms for heavy use, you need to be aware of what Request Manager can do, but you also need to be aware of how it fits into your farm. Both of these, distributed cache and Request Manager, can run on your web front ends. No, you will not be able to use the same hardware allocation and memory allocation you used on those web front ends before in order to run both of these services. They both consume a lot of process time. Okay? You need to scale those web front ends up from where you had them before, all right? And or you need to plan to run them independently. There's also some ancillary stuff that we never had to think of before that now we do. The first and most important one is apps. If you're running apps in SharePoint 2013, right, especially on-premise server to server, you need to be aware of the load that those apps are going to put on your environment. Apps are disconnected from the farm by default. They have to have a way to communicate with it. How do they communicate with it? Over HTTP, primarily via REST calls. Okay? That's a whole lot more hits that are coming to your web server. Before, they came to our page, there was a web part on the page, we had compiled code running in the background, right? And it was just part of the page load cycle. Now we're going out to an app that's then calling back in via a bunch of HTTP REST calls to our environment, putting more overhead on our web front-end servers than it did before. The more apps you have, the more overhead you're introducing into the top tier of your architecture, okay? Same for Windows Azure. What if you're doing Service Bus through Azure in a hybrid type of scenario? More calls coming into your web front ends. My recommendation, and this is not a best practice by any means, but my recommendation is if you're going to do a lot of this, you need to have more of these, and preferably they're isolated. They do nothing but talk to apps and talk to things like Azure. And then finally, if you're doing a hybrid scenario in Office 365, that's a lot of auth that's going back and forth. You may have OAuth running in that type of environment, right? There's even more chatter coming back into your farm. You have to architect for all this stuff up front. I know it's a lot more to think about, a little bit more complicated, but you need to get it right on the front end. All right, let's talk about the distributed cache. So this is an interesting new component in 2013. The distributed cache is there to service things that would normally require database calls in the old architecture. But the important thing to know about the distributed cache is it exists outside of all the other cache mechanisms, and there is no database persistence to the distributed cache. Things go into memory, and once that server recycles or reboots or the cache gets flushed, they're gone. Unlike our blob cache, which is disk-based, or our object cache, which is SQL-based, this stuff is in transit all the time. If you're relying on things in the distributed cache, sooner or later, that's going to come back to bite you. It has a configurable memory allocation. By default, the distributed cache runs on your web front-end servers and takes 10% of the available memory on that machine. We're still early in the cycle, so there's still some conflicting information on TechNet about that. You'll see some that says 5%. In RTM, it's 10% of the available memory on that machine. That does not reconfigure itself if you change the parameters of the virtual machine. So if you start with, say, an 8 gig virtual machine and realize that's not sufficient, dial it up to 16 gig, the cache won't reset itself to 10% of 16. You have to manually go in and change it yourself. Okay? And if you're changing that allocation on your web front ends, there's probably a good reason for that, and the cache should be changed as well. It can run in 2 modes. Either co-located, which means it's running on your web front ends, like we talked about a moment ago, or dedicated, where it runs on its own set of boxes. Those boxes are web front end servers in your architecture. They require a server license. You need to think about, do I need a dedicated cache in my environment or not? That 10% of memory that it's taking, that's in addition to everything else SharePoint 2013 is doing. Okay? So if you've already looked at the hardware requirements for 2013, you know it's much greater than it ever was in 2010. You're not going to be able to get away with these skinny 4 and 6 gig VMs on the web front ends anymore. It's much higher than that. And if you plan to make any serious use of the distributed cache, you're going to have to add extra resources. What things in 2013 depend on the distributed cache? Well, as it turns out, a whole lot. Let's start with the login tokens. Right? A key critical part of our architecture. If we can't authenticate, then nobody's getting to anything. The whole token cache is stored in a distributed cache. We also have for access services, that's stored in the distributed cache. Here's the biggie. All your social stuff, or a good portion of it, is in the distributed cache. Your feeds, your document activities, your likes, all that stuff is in a transitory cache. So if you, and this will happen to you at some point, your feeds will disappear, okay? A web server will get recycled, something will happen in your environment, and the next thing you know, all your feeds are gone. Hey, what happened to my feeds? Well, they were in the distributed cache and it got reset, okay? Another piece you need to be aware of is that every server running the distributed cache has to have the exact same memory allocation. You can't have one with 8 and one with 4 or any mixture thereof. They all have to be exactly the same, right? Part of that reason is because the cache it's called distributed cache for a reason. It's distributed across those boxes. The idea is if one goes down, the other can pick up. But it doesn't always work that way in practice. The search query web part, one of the killer new web parts in 2013, depends on the distributed cache. Okay? It performs great after the first time it's read the index because it's cached. Okay? If it has to be recycled all the time, then that great web part doesn't perform so well. The last modified cache is primarily for document activities and whatnot that you're seeing in your feeds. Security trimming. It's been a big problem since 2003. All right, the whole security trimming architecture put a lot of load on the database. In 2013, they've moved that into the distributed cache, but once again, it's transitory. So if that cache gets depleted or recycled, the next time people start logging in and your beautiful 15 layers deep navigation tree that was performing great, all of a sudden it takes Pages a long time to load, well, you probably know where the culprit is. Okay? It's having to security trim all that stuff again. OneNote, there's some throttling mechanisms around OneNote, which you know has that constant save feature. So there's some throttling there that depends on the cache. App tokens, if you're doing a lot of app development, in 2013, all those tokens are cached, along with the view state cache, and there's a generic bucket for a default cache. Okay? That's a lot of stuff. Okay? The distributed cache is pretty darn important. And stuffing all of that in there in the default configuration of, let's say, an 8 gig machine and you have 800 megs, might not cut it in your environment. Depends on how much of that stuff you're using. I can tell you now, if you're doing a lot of social stuff, that default config's not going to work for you. You're going to need to dial it up. All right, here's some guidelines. All right, some numbers that you can refer to. A couple of important things that you need to know. All right, we already talked about the manual adjustment. If you change the allocation of the memory on those virtual machines, you need to go in and manually adjust your distributed cache. There's a limit of 16 gigabytes in the cache per server. So no matter how big and beefy that server is, you can only have 16 gigabytes in the cache on any one server. And the max size of the cache throughout the entire farm is 32 gigs. Basically what that means, it's an N+1 configuration. So even if you have 4 web servers, you really only have 32 gigs of cache because each one is maintaining a copy, okay? The memory size must match in all the servers, otherwise you're going to get errors. You're going to see the ULS start filling up with errors about memory mismatch for the distributed cache, okay? And that's the reason. Okay, here's what I love about this slide. I don't know if anybody have noticed this yet. I know you really can't see over there, it's difficult. they define a small farm as less than 10,000 users. All right, is that your small farm? It ain't my small farm, right? 10,000 requires a little bit bigger farm. Oh, a large farm? Until you get to 500,000, why worry about it, right? I don't know who writes these guidelines, but we're on something funny. Okay, let's look at how you configure the distributed cache, all right? As with just about everything these days, it's all in PowerShell. So there's some PowerShell commands that you can run to adjust the various configurations of the distributed cache. First thing here is I've got some scripts for you. These are all pretty well documented, but I will post them afterwards so you all have access to them if you need them. Let's adjust this a little bit here. Okay, so here I'm getting the cache configuration information for my farm. So I have one single server. Here's some basic information about it. And here's how much I have allocated. I have a 12 gigs to this server, so I have 1,200 megabytes in the cache, okay? If I want to adjust that, I can change that setting. I can move servers in and out of the cache, so let me show you how to do that. You'll also notice there's this value down here called isLeadHost, right? This is the N+1 configuration that I'm talking about. You'll see that you'll have one lead host in each one of your farms, and the others essentially are copies or backups. So adding a server or removing it is pretty easy. Let's start with removing a server. It's going to love this because it's the only one in the farm. I can run that one and it'll say, okay, I've taken your distributed cache out of the farm. Now I can't have any social. Excellent. I've turned it off. Cool, like disabling my sites. Now if I want to add one back in, again, also a very simple line of PowerShell. You just add it back in. There's nothing really to configure on that for that piece of it. And it's going to think about it for a minute, and then it's going to add it back in. It's going through and allocating all the memory for me. Eventually, there it goes. Okay, now, you can also stop and restart the cache. So if you want to stop the cache service, if you're trying to debug a problem or something's going on, you can do that here, right? Where you're calling the distributed cache service, and you're getting the service instance, blah, 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 and you're passing in a long scrambled name. I'll show you the rest of the script here, and you pass in the environment, computer name, whatnot, and it goes boop, unprovisioned. Okay, this is a bit of a scary command because if you run this, it's immediate. It's kind of like taking something out of the cluster without drain stopping it first. It just cuts everything out of the cache, right? Boom, gone. Everyone's feeds disappear, right? There's another way to do this. You can gracefully shut down the cache with the shutdown command and this brilliant parameter called graceful. All right, so run that and it will drain out the cache before it completely turns it off. I recommend using that command as opposed to the other just boom, off with your head. All right, and then if you want to turn it back on, then you can just start the service again and same set of commands and it'll spin it back up for you and reallocate everything. All right, the one that you'll probably use from time to time is setting the cache. So here's the command to use for setting the distributed cache. You're setting it in megabytes. So let's say I want this one to be a little larger. I'm going to dedicate 2,000 megabytes to it. Yep, fine. I'll go ahead and do that for you eventually. And then I can come back and display my cache information. It's chugging along. It'll get there eventually, I promise. Someday. Working on it. All right, maybe it won't. Well, it's going to set it to 2 gigs for me, and then I can go back and I can check the memory, and it'll show me that I've got 2 gigs allocated to it. Okay, remember to run this. You'll only need to run this on one server in the farm. Okay, it'll adjust all the servers for you. So you don't have to go and run it on each one. It'll take care of that for you. All right. So you only really need to do this if you think you're running out of memory there, you're seeing errors in the ULS log, boy, heck, it's taking forever, or you've changed the memory allocation on your servers. Okay, so pretty basic. There's not a whole lot to managing the distributed cache. The most important thing you need to decide is whether you're going to run it in a dedicated mode, requiring another box, or whether you're going to run it in co-located mode, running on the front-end web servers. And that may or may not ever complete. Yes?
Increasing the size of the cache, does that clear it as well while it does it?
Yes, it does. Yeah, so it's a destructive operation. Yeah. Okay. Request management. All right, for those of you who went to Spence's session, a little bit of a repeat here, but I want to talk to it from a performance perspective for you. Request management is an interesting new animal. One of the big problems that we've had in the past is that we were using hardware load balancers to manage and shape our traffic load, but they didn't have any clue about how SharePoint operates. Okay, how many of you have ever had the misfortune to have to write an F5 I rule? Nasty stuff, okay? Great concept, right? Put some intelligence into your load balancers, love it, but those things don't know anything about SharePoint. So you can tell it all day long, send traffic here or send traffic there, but if that SharePoint server is already performing not up to spec, you're just going to be sending traffic to a poorly performing server, okay? Not a great idea. So the concept behind the request manager is, let's put some traffic shaping in place that knows about SharePoint. Let's get it into the farm where it can start to interact with what's going on behind the scenes. So it's really a SharePoint-aware, rule-based traffic shaping mechanism. It does really 4 distinct things. It does traffic throttling, right? So squeezing down requests that you don't want or that should have minimal bandwidth, right? Routing requests to specific servers, components, prioritizing some requests over others, and finally, balancing the load across the various components in the server, or in the farm, okay? There's 2 modes. Integrated, it runs on your existing web front-end servers, okay? Doesn't take up a whole lot of memory unless you're throwing a lot of traffic at it and you're doing some complex rules, then you may need to think about beefing up those front-end web servers. But it can also run in dedicated or Office 365 mode, which is having your own request management servers. I love this architecture, right? We have 6 RM boxes and we have 4 SharePoint boxes. Somebody over-engineered this just a wee bit. All right. The basic concept here is traffic comes into an RM server that exists as SharePoint boxes, right? So some of you are doing the math and going, ooh, that's a license for each one of those. Have to have a dedicated configuration database for them. And then that traffic gets passed on into your actual SharePoint farm. So think of them as a SharePoint load balancer, okay? Which is really what they are. If you're going to run in that mode, A, be prepared for the cost, right, because it's going to be expensive, and B, be prepared for a lot of PowerShell configuration, because there's a bunch that you're going to have to do in order to get there. Most of you will never get to this point. Most of you will probably run in integrated mode, just bump up your web servers a bit, and that's perfectly fine. All right, what are the components? Let's start with throttling rules. These are rules that basically say thou shalt have access or thou shalt not, or thou shalt have only this little tiny bit, and I don't want to give you any more than that. Where would you use that? Oh, I don't know. Crawlers, you're on a public website, right? You got all these search crawlers coming in and hitting your website. Why should they have the same priority as one of your users who's actually trying to get data, right? Let's throttle those guys down, give them a really narrow pipe. Then we have machine pools. These are fairly self-explanatory. They're pools of servers. We then have routing targets. These are the individual servers, right? We need new nomenclature because we can't just reuse like group and server. That would be silly. We need new terms for those, okay? Gives the TechNet author something to do. Those routing targets can then be weighted statically or using their health score, okay? How many of you know what a SharePoint health score is? Let me see, okay? All right. You want to know what it is? Fire up Fiddler, make a request to a SharePoint site, and if you look down at the very bottom of the response, you'll see this X SharePoint health score come back, and it's a value of 0 to 10. Okay? And the higher the number, the worse that SharePoint farm is performing. Right? There's some internal calculations that it does on the back end to determine what that score should be, and probably some long, complex algorithm that like only 2 people in Redmond know what it actually does. But it spits you back a value that you can then use to determine the health of the farm. Okay? You can use that in your request management and your rules to determine who should get what kind of traffic. Routing things to healthy servers, for example, and not to unhealthy servers. But if that doesn't quite work for you and you need a little more control, you can also statically weight requests as they come in. So I can say I want all of this type of requests to go to servers 1, 2, and 3 as opposed to 4, 5, and 6 because they are beefier or they're in a better network or what have you. All right, we then have execution groups. These are groups of rules that we're going to run, and here are routing rules that go into the execution groups. Okay, these feed things down to our routing targets. Here's how it looks in practice in an actual architecture. Okay, we have our throttling rules. This is the first piece that gets run. We then have our execution groups. Thou shalt be only 3 and no more than 3. The first rules that you create will automatically go into the execution group 0 unless specified otherwise, but you can only have 3 of these. It will go through them in order from 0 to 3. We then have our machine pools that contain our servers. Okay, these are our routing targets down here. So here's what happens. A request comes in, it hits the throttling rules, and the throttling decides it goes through or it doesn't, or I'm going to squeeze it down. That's it. That's as intelligent as the throttling rules get. Then if it passes this test, it then goes to its execution groups in order, 0, 1, 2, 3, and it checks the rules. What that rule says determines where the request goes next. If, for example, it meets rule number 2, you may be sending here static or health weighted to server number 1. You could be shooting it over to this machine pool over here, and so on and so forth. Okay? So this is where the real magic happens in your rule matching. You need to be careful with these rules because they're mostly regular expression based. Okay? So if you come up with some wild regular expression you copied off the web somewhere, there could be a fair amount of processing. And this stuff is happening before the user ever gets a response. Okay? So you need to be a little bit careful on this layer that you don't get crazy with these routing rules. There's some counters around this that you can watch in your environment, and if you implement request management, I strongly suggest that you also pay attention to the counters that are there for it because it can come back to bite you. How many current connections you have, how many are being reused and made, this is the important one, routed requests per second, and also throttled requests per second. So if you think in 2010, on the web application screen, right, we had one thing for HTTP throttling down at the bottom, right? We could flick it on or off. Now we get to control that mechanism and add some extra intelligence to it, but there also wasn't really anything there to tell us when it was happening and how it was happening. So now you can watch all of these counters for that. All right, let's look at how to configure it because this is rather entertaining. I hope you like PowerShell. All right, let's start with looking at what's going on in our environment. So let me close some of this distributed cache stuff so we have a little bit more room. All right, so let's start with displaying our RM settings. All right, so I'm going to fire that off, and we're going to look at what's going on in our environment. Let me scroll up here. There's a fair bit of it. Okay, so starting here, here's where we're saying whether routing is enabled in our environment, what kind of routing scheme that we're using, and a few other things down here that we need to know about. All right, what's happening in the farm. But the good stuff is right in here. Unfortunately, this tells us if throttling is enabled, yes, but what we're really concerned about are what rules and machine pools and targets we have. These are just collections at the moment. This one down here will tell us what our routing targets are. So I have, by default, the server I'm on is a routing target, so it puts it into the pool. You can pull routing targets in and out. It doesn't have to be all of your servers. It can be any server that you specify. For example, if you wanted to direct every request for, say, an Excel file, if you had Office Web Apps enabled, you could send all of those requests to a very specific server, right? In this case, you would only have your web app server specified as a routing target, okay? Pretty simple scenario. Whether it's initialized, et cetera, and some other values, okay? If you want to know more about all this stuff, refer to Spence's presentation from earlier because he goes deeper into all these configurations. What I do want to show you is there's a few commands for getting your routing machines and targets. Those should be isolated to the incoming server in this case, but here's the PowerShell if you want to look through it. Let's start with creating a routing rule, okay? So I'm going to do a few things in this script. First, I'm going to get the web application. Everything is done on a web application basis, all right? Take note of that. If you decide to deploy this rule and you have more than one web application, you're going to have to assign it to multiple web applications, okay? First, we're going to get our request management settings. Then we're going to create a new rule criteria, and our rule criteria, I'm sorry, this is hard to see for y'all over there. The rule criteria here is match everything that ends in .xslx. So those are all my Excel files, okay? So I'm obviously routing this to Office Web Application Server, okay? If I don't have a routing machine pool, create one for me. You can see that here. It's called demo pool. Let me slide over so you can see the rest of that command, okay? And what are my machine targets? Well, I'm going to set it here to this specific target. Send it to this one right here, 2013 demo. Okay, so there's my collection. I'm just piping it out to that set. And then finally, add the routing rule with the name Excel rule and give it my criteria that I established here. This is my actual rule where I matched the end of the URL, okay? And assign it to my machine pool that I set here, okay? So specify my criteria, create the machine pool, and then assign the criteria and the machine pool, all right? So we're going to go ahead and, if I have everything right, I'm going to run it. And it says, warning, using irregular expression matching can be dangerous, more expensive than others. So it's trying to help you help yourself. Okay? You can also match on, there's source IP addresses, you can match on header content, right? There's a couple of different things that you can match on when you're creating these rules. Most common will probably be regular expressions, even though that does introduce a little bit of overhead. Okay, so it's created a rule for me now, and it's also created a machine pool. So let's have a look-see, and we'll see. I'm going to look at my rule that I just created. So here's getting my request management setting, routing rule, Excel rule. Tell me about it. Here it is. The property type is URL. The value that I'm matching, looking for is XLSS. It's regex, and there you have it running. Okay. I've also created a machine pool, so I can check on that machine pool here, and it will tell me this is your machine pool. Here's the server that's assigned to. You can see here's the name that we assigned to it here, the demo pool, and I can look at what rules are assigned to there, whether it's online or offline. Now, let's say I messed that one up, and I don't like that routing rule. I need to remove it. Okay. Here's a script for removing the routing pool for you. So you just identify the rule, you can run it, and it'll take that rule out. Same with the machine pool. I can run that script and take the machine pool out. And now when I go back to my RM settings, they're going to look pretty much like they did the first time around. I don't have that machine pool or that rule existing. And we can see that by going back to the routing rule. Where is get my routing rule display? Where is it? Oh, there it is. And you'll see when I run that command now, it's saying, oops, I can't find that. It doesn't exist. Okay? There is no UI for this, so it's all done through the PowerShell, so you need to keep track about what rules you have running where and what web applications you've got them on. What I've found is where I run into the most trouble with this is I add a new web application, and I forget that I've got a routing rule already running on another one, and I need to go reset this up for the new web application. Okay? Now, there's a lot of discussion, mostly internal, on will you actually use this in production and what will you use it for? Well, I was talking to a couple of folks earlier about some scenarios where this is useful. I happen to think it's highly useful because I now have the ability to shape my traffic coming into my farm in a way that I never had the ability to do that before. That can be really critical, especially for large WCM implementations. Okay? But some of the scenarios that came out were, what if you're a financial institution and you have large year-end financial processing that has to happen? Okay, everybody's suddenly hitting Excel and the Office web apps, right? Pulling down all these Excel spreadsheets or hitting Excel services. Well, these kinds of rules can be helpful in diverting those to dedicated boxes. Maybe you spin up a dedicated box for the length that you need that, and then you spin it back down. Okay, now you don't have that resource that's out there all the time, and you can use the request management to shape it. We've had big problems in the past on public websites with search crawlers. How many of you are running any big public-facing WCM on SharePoint? Okay, nobody in here? This is a problem. The bigger your site is, the more Google wants to crawl it, and then you've got Bing and Yahoo and AOL and now Facebook, and everybody and their brother's trying to crawl your website. The more content you have, the more time that can take. So having the ability to throttle those down and hand those off over here and say, okay, you get a narrow pipe you get to crawl from, can offload a lot of that coming in to your farm. Okay? Does that make sense? Any questions on the request management piece? Okay. Yeah.
Presumably, you could have a rule for Bing, Google, and Amazon Publish, a separate rule for each?
You could, based on source. If you can, yeah, because you can look at the headers, right? And you can see, based on this, source or MIME type or what have you, then yeah, you could run a rule for each one of them. So what you're saying is you would give Bing full access and throttle down Google? Is that what we're saying?
Oh, I wouldn't dare do that.
Or the Microsoft people? Yeah, right. But yes, you could.
You could, but you also have a rule which says any of these buggers from Bing or Google, whatever, push them out,
Yeah,
something.
could do. Yeah, absolutely.
And how would you do that?
You would look at the header content, right? You would match on the headers, right? And they all have, I forget what it is, but most of them have a application type, right, that tells you it's a spider, right? Or you can look for anything that's trying to hit robots.txt. Okay, that's the first file they're always going to request when they start a crawl, right? So you can say, if you're asking for robots, you're a search crawler. Go over here. Yeah. Or instead of throttling them, you could just decide to hand them off to one box. Okay, search is important to me. In a lot of WCM scenarios, search is vitally important, right? Especially with the new SEO-friendly stuff in 2013. You could say, I'm just going to dedicate a box to that, right? And let it talk to the search engines all day long. Okay. Shredded storage, yes.
Can be used to sort of deal with brute force attacks in public, or is that more of a hardware filtering based?
It's more of a hardware filtering based. I'm not saying you couldn't potentially do that, but it's not really looking for attack configurations, right? So it's not going to see thousands of simultaneous requests to the same source as, I never normally get thousands of requests at this time, right? Whereas your more intelligent front-end load balancers will look at that sort of thing, right? Okay. Shredded storage. Man, this is cool. We've needed this forever. What's the point of shredded storage? Well, the initial point is to drastically reduce the amount of I/O between your front-end tiers, front-end webs, and your application servers, and your back-end database. Okay? What it's doing is instead of grabbing full blobs out of the database constantly on these back and forth round trips, it's now doing incremental changes, both reads and writes. Okay? So if you weren't aware of how it worked in the past, in 2007 and 2010, whenever you changed a document, it wrote the whole thing back to SQL. Right? Whenever you asked for a new version of the document, it gave you the whole thing back out of SQL. Okay? That's not very efficient. There's two components to shredded storage. There's the client, which only applies to Office applications. Okay? That would be Word, Excel, PowerPoint, etc. On the client scenario, it will actually look at the original file structure, any changes that you have made when you click Save, and it will only persist the changes. Okay? That's cool, but it only works for Office applications. If you're doing PDFs or DWGs or what have you, it's not going to help you in the client scenario. But the server scenario applies to everything. Okay? What it's doing under the scenes is it's looking at the original blob, and if it's a first-time save, it's going to save the whole blob, okay? Or a first-time read the whole blob. On subsequent changes, it's going to, there's two new database tables that it starts writing stuff to, and it starts writing each of those incremental changes. When you request the whole document, it will go through and bring all that together and deliver it back to you. But during the write cycle, it's only writing those thin slivers of changes back to the database, right? Same amount of activity means you're making a write, but it's much, much smaller than it was before. It also means that when we're designing our storage capacity for our farms, because shredded storage is enabled by default, if you have a lot of documents that you use in a heavy collaborative scenario, the old rules that applied to how much database storage you needed for your documents have been drastically reduced. Okay? The goal is 2 times. I haven't seen yet any field level data to say whether or not this is actually true. It depends on your farm configuration and what you're doing, but there is a significant reduction in your environment. Okay, there's 2 parameters that you can adjust for this. You can turn it on or off. I don't recommend turning it off. And you can change the file read chunk size and the file write chunk size. Basically, this says, this is the smallest amount of data that I will look for to change before I create a new shred in the database or enter a new row in that table. Okay, so you can dial this up or down for what may make the most sense in your organization. If you want to cut down the amount of chatter to your database, you may want to raise this up, but if you're primarily concerned about the actual data storage, then you would want to dial this down and potentially leave it as default. Okay, here's how it works in practice. Your end user, if they're in an Office application, will make a change, will make a request to the document. They'll get the whole document back. SQL takes all the various rows, puts them together, hands them back to the user. If they're using an Office application, it will see that they've only changed one sliver. It will write that sliver back to the database. If they're not using an Office application, all right, it will simply write the entirety back to the database as a new file read. But when it, or as a new file write. But when it reads it, okay, it still knows that I'm only pulling the last chunks out. All right, any questions on shredded storage? Yeah.
The combination with remote blob storage.
Yes.
I've heard many theories about that, and one of them is that if you have remote blob storage and shredded storage, it's not optimal. Because it was better to disable shredded storage by decreasing the size of the chunk size.
And I've heard the same argument. So let me rephrase the argument. The concern is that if you have shredded storage enabled, it's not optimal with remote blob storage because you have all these now incremental writes that you're making, right? And that all that has to be brought back together. And what it's actually doing is every time it has to store that blob, it has to pull all that together to store it as a blob, right? I'm not going to give you an opinion on that. I've heard both sides of the argument. And if you have remote blob storage enabled, first you need a really good reason to enable RBS in the first place, okay? And there's a lot of considerations you have to make if you are going to implement it. If you do implement it, then you need to think about, do I want to have shredded storage or do I want to increase the chunk size that's going out there? There's another big concern around backup for all of that, right, and how that's handled. I would say that you just probably need to look at your scenario and see which one makes most sense for you. In most cases, you're going to want to leave shredded storage enabled. Okay. Was there another question? Yes? I don't know the answer to that question. Does anybody know? Does Office 365 implement shredded storage? Do we know? Drop me an email on that, okay? I'll go find out. It's 2000, SQL 2012. First shredded. Wait, will it work on R2? Will it work on 2008 R2? Yeah, 2008 R2 and up.
It's not if you upgrade, right?
Pardon?
It's not if you upgrade. It's not by default. You have to go back and manually.
You do have to enable it on SQL 2008 R2, I believe. I believe it's enabled by default in 2012.
Is there something where you have to go in and actually?
Yes, you do. If you're in an upgrade scenario, thank you, Mary Lee. If you're in an upgrade scenario, you need to enable shredded storage in your upgraded farm, right? Because it won't be turned on by default. Unless you put it in your scripts or you have a set of upgrade scripts that do that, but it isn't by default. Okay, let's talk about the user interface, okay? First thing you need to know about the UI in 2013 is there's a whole bunch of JavaScript. Yay, where are my developers? Boo! I'm with you. All right, so a lot of client-side rendering going on. All right, if you're in an older organization and the machines they have aren't so hot and they're still running IE8, then client-side rendering ain't such a hot ball game, right? But it's there in 2013, so be prepared for it, okay? The markup has been optimized. Thankfully, we've got cleaner HTML. There aren't a whole bunch of tables running loose everywhere like they were in the past, but that means a heavier dependence on CSS and dependence, of course, on more JavaScript. There's something new called minimal download in 2013. We're going to talk about that more in depth in just a second. You will like this, I promise. We also have a really cool new thing called image renditions. Okay, are there any design professionals? How many of you have done UI design stuff before, whether you wanted to or not? Okay, all right, so we've got a few of us. All right, so one of the problems when we've got mobile devices is that we can specify image sizes for mobile devices, but the full image still gets downloaded. Okay, so if you have a 60K image and someone's browsing it on a handheld device, even though the image is displayed smaller, the whole image still gets downloaded. In 2013, we now have image renditions. So you can take an image and you can specify, I want a medium size, I want a small size, I want an extra small size. Okay, and when it sees a request come through for a specific device channel, it will deliver back the optimally sized image. So now you take, say, a 60K image for your small device, it's down to maybe a 15K image, and that's all you're sending across the wire. Okay, so image renditions are cool, and they're in the UI, so you can just upload your image, and then you can do your renditions, assign it to your channels, and you're done. Right, it's pretty slick. Speaking of device channels, we now have device channels in 2013, so you can specify I want this content rendered to this particular device, right? So if iPhone, just show black. If Windows Phone, give me a beautiful interface, okay? You didn't like that. You're a bunch of iPhone Nazis. All right, but we do have device channels so you can optimize for various different platforms, which is really cool. And then we have possibly my favorite new feature, which is the content by search in the user interface. So content by query is gone, yay! And all that XSL. And now we've got content by search. It uses a search index, which is excellent. And if you're using a lot of data view web parts or content by query, you're absolutely going to love content by search, which depends on what? Distributed cache. Thank you very much. Somebody was paying attention over here. All right, let's talk about minimal download. In 2010 and previous versions, whenever you made a request to a page, you would get all of those beautiful SharePoint controls get rendered behind the scenes with a lot of talking to the database and all the other stuff that they do. And it would build itself up into a page and it would send it back to you. Okay, great. The next time you made a request, all those controls get to be rendered again, right? It talks to the database again and it sends it back to you. Boo, hiss, that's not so great. Okay? Made our page payloads really heavy in previous versions. In 2013, we now have a concept called minimal download. And what this means is, if the controls are instrumented for it, and this is the important part, it will only deliver the changed content in that control. Okay? It will not re-render controls that have not been changed. All right? So, scenario. You have a publishing site and you have a lot of navigation, right? You have a hierarchy menu in there. Okay? Those security trimming for those menus is very resource intensive. In minimal download, if those controls have not changed from page to page, it will not go out and refresh them. In a sense, it will cache them, right? And you will get the same rendered content back without having to request it again. That's a huge improvement over 2010, okay? And it squeezes down those page sizes. Now, there's a couple things you need to know about this. One, the controls have to be instrumented for it. Okay? Most of the out-of-the-box controls are, but if you develop custom controls, if you're doing delegate controls, or you have third-party web parts or what have you, they have to be instrumented for it to work. Okay? The second thing is, this results in a really funky URL. I don't know if you've noticed, but with the default page in SharePoint 2013 says #start, and then it points you over to 15, and oh, there's my home page. It's around here somewhere. What's happening is the download manager is sitting in between, okay? And it's saying, here's where I start. Okay, now this is the page I want to fetch. I'm going to analyze it to see if my controls are instrumented, right? And I'm only going to send back this content that's changed. Okay, this is not so great for WCM strategies because you want clean URL paths, and the download manager and clean URL paths don't really go together. There are ways to code around that, but it's not so easy. Okay, this is primarily an internal collaboration scenario. Waldeck's shaking his head. I know because he's written on this, and this can be ugly, right? Did you guys even try to do this on your public site? Yeah, it's ugly. But in an internal collaboration scenario, if you're not worried about clean URL pathing, it makes your pages so much more responsive. Right? It's good stuff. All right, let's talk about page rendering. They've done some significant improvements in the rendering model. So here's a standard 2010 page, default team site, straight out of the box. All right, a little bit of analysis on it gives it a weight of 300K. That's not so hot. Okay, in 2013, we're down to 186K for the default page, same set of web parts. Okay, not bad. That's a pretty good improvement from 2010 to 2013. Okay, page weight. Well, in 2010, our average page weight had 29 requests or more. Again, this is the same default out-of-the-box page for a weight of about 570K. Nobody uses the out-of-the-box default page. We've all got all sorts of stuff running around on there, so usually our pages are even heavier weight than that. In 2013, the default page narrows those requests down to 21, but more importantly, takes it down to 321K. By the way, the difference between the slide before and the slide after is this is all the delay-loaded stuff, okay, that comes in afterwards. And there's a bunch of it. If you fire up Fiddler and watch what's going on in 2013, you'll see all the script delay load stuff, that's happening. So the page comes up and responds, and then it's loading all that stuff behind. The really important part about this graph is where this red line is right here. Okay, this is time to usability, right? So this is when the page content has been rendered. Look how far it moves to the left in 2013. All right, that's all the delay loading stuff happening. So it's giving you back a small set of optimized HTML, and then it's going and doing all the asynchronous stuff in the background. So it gives the users a perceived increase in performance. Perceived. Okay, if you've heard me talk in the past, you know how much I love jQuery. Okay, these JavaScript client-side stuff, it's great, it's cool, but it's not a real increase in performance, right? If the page loads and something on the page still says working on it, the page ain't done, right? There's still a spinning logo does not mean the page is finished. The page is finished when the page is finished, okay? So the important part here, my takeaway here, is that the base page load has been decreased, and that's a good thing. Make sure you adhere to this in your design. Okay? Make sure you're minifying your JavaScript and your CSS files. Don't get crazy just because we're now in 2013. Let's remember the old rules still apply. And if you are going to be adding additional overhead to this page, things like client web parts, okay? That's an iframe that's going to go out and call an app and come back, right? Make sure you're managing things like the asynchronous process that does that, and you take that into consideration about your actual time to usability versus your perceived time to usability. Okay, all right. We are pretty much at the end. I'll leave a couple of minutes here for questions. So just to wrap up, there's some architectural concerns that you need to be aware of in 2013, especially around these additional functions like distributed cache, request management, and especially apps. Understand what the distributed cache can do for you and also what it can do to you if it happens to go away. Decide whether or not request management is something that you need in your environment or that you need to configure. Take advantage of shredded storage, which thankfully is turned on by default, and then pay attention to the changes in the user interface. Okay? Any questions? Anything performance related?